have this skill, yeah, to understand and to explain, because Ali, believe me, I have more experience on the building and construction, not in the design. Yeah, I understood very good design to implement on the field. Yeah, on site.
Perfect. Yes.
I know. Yeah, I can read many kind of projects, design projects. But I want to understand how to achieve these results, what we have on the site to implement or to execute on the on the project. But my what is it? I don't know if I could explain you.
Really? So I see you have like a knowledge in the practical field. You have the basics. You have maybe experience. I mean, practical experience, like reading the plans, the details, the reinforcement, the practical experience. But you need, and also you have technical experience, but you need to integrate the practical experience with the technical experience, especially also with conversion with manual design and ETABS. And this is the point. I mean, a lot of engineers can do the manual calculations, but once they come to the point of ETABS or any other software, they have like issues with dealing with that software, because they don't have the let's say they don't have the background. I mean, the behind of sense of ETABS, how it's working, what's the parameters there, what's the inputs, what does, for example, stiffness modifiers in ETABS is really are, what they do in the design, what's the effect of the design, how we also make the equilibrium, compatibility, deflection checks in ETABS regarding beams, slabs, and let's say also for let's say the systemic design in ETABS, the finite element analysis, the meshing. Sometimes structural engineers do the model. They can do the model, but once it comes to the design checks, they just make the mesh, a general mesh, without reading that mesh. Is that really connected? Because when we have a slab, this slab is divided into small meshes, okay, where each mesh has like, let's say if it is a square or rectangle, so we will have 4 nodes, and these nodes will be connected with the just nearest mesh. Okay, so each mesh is connected to the nearest mesh. This make the big entity of a slab. Also, the beams need to have a mesh. Also, the columns. Also, the footing. And if we didn't make that mesh, this means that we make the analysis as a whole entity. Therefore, the accuracy of the deflections, and the moment, therefore, the internal forces, the shear, the axial force, the torsion will not be accurate, will not be related to the experience, to the practical experience, related to the field work. Okay. So I see you have the level, let's say basic to intermediate, but you need to focus on, let's say, after the modeling, or let's say model the structure. Let's say we have 8 floors structural building, and we need to apply all the loads. And before that, we need to do like a note for us, structural notes. Okay, this note will have like the load combinations, how we estimated the loads, the ACI code standards for, let's say, live load, super dead, and so forth, and like how to do the manual calculations of a beam. Okay, designing the shear, designing the moment, and also for the columns. Okay. When it comes to the columns, we have like 2 cases: cylinder columns, where the height is very thin regarding or relative to the dimensions of the column. So if we have like a column 6 meter, but this column is 0.6 by 0.2, okay, and we have like let's say a building, an office building, therefore the live load, the super dead load is very large. So we will have a large axial load acting on the column. This make indirect tension and also make buckling failure. So In design columns, for example, it comes to the point of compression axial force, but also we need to consider other failure modes. Okay, and ETABS, once you like make the dimensions of the column is 6 meters, and in the practical field you make like a bracing, I mean, let's say a beam in the middle, okay, of the column that has the height of 6 meters, the acting of buckling failure will not control the case of failure because we make a bracing in the middle, okay? And for example, it is related to the dimensions of the column, the geometry of the column. We have 0.4 by 0.4, I mean a square shaped column. The acting of buckling failure is different from saying have the same area, okay, but if we have a rectangle shape, since the rectangle shape means we have large amount of inertia on the dimensions, the large dimensions, okay, and the smallest dimensions we have weak moment of inertia, since the buckling will have on that side, okay. So here the point is to do the manual calculation, absolutely, but we will not make the manual calculations for each beam, for each column, for each slab, if we have multiple floors, for each footing. No, we will make a check, for example, on a point in the mesh, in the slab, how to estimate that moment, how to estimate that area of steel, how to compare these values in conversion of ETABS. If we did all of these points for a beam, let's say, and a column, okay, and a footing, since we have do that checks in ETABS. 3 checks in ETABS are essential for structural engineering. Equilibrium check to ensure all the structural elements are working together, okay? Then the compatibility check, okay? And also we have internal forces check. I hope these informations are helpful. Do you have any questions at this point?
Sorry, at the end, the signal was cutting. Internal, you said internal, I didn't cut.
We have internal forces. What is the internal forces for a column, let's say? We have axial force, okay? So we need to compute that axial force acting on the column by what it's said, or it's called in ACI or in design, concrete design, tributary area. Okay, this is approximated way, approximated methodology to estimate the axial load, okay, on the column. Since we estimated it manually, we will compare this axial load on a column. Let's say it's C5, okay. Regarding to the ETABS value, what is the difference? Is that approximated? Is that near value, or it is a very far value from the manual design, and why? Did you get the point? Do you have any questions regarding this point?
Yeah, sorry, but the signal is cutting, and sometimes I can't